Hey, hi, how are you? This is a video showcasing this project I did on my Tormach 1500MX. This is a valve cover for a Gen 2 Dodge Viper. Started off with doing some spot drilling and then some peck drilling about halfway through the material. What makes this project kind of unique for me is this is a piece of material that's a little bit larger than the work surface of this machine. This is a 25-inch piece of aluminum, and the machine has a 19 and a half travel on X. So this did require moving it over and doing a second op on both sides. You'll notice I have some green dots on the fixture plate. That actually shows you how far the travel is X and Y of the machine. So here I've got my 3-flute chip breaker end mill. This is a 1/2-inch tool with about 3 inches of stick out from the tool holder. This allows me to get all the way down to the bottom of this valve cover. The material here is about 4 inches thick and about 5 inches deep. This tool really was the star of the show. It had the most spindle time and helped really keep chips compact, being a chip breaker tool. This being about, almost 3 inches deep on its deepest part, really did. You can see how close I'm getting that tool holder to the material here. And you'll probably notice that this is a shrink fit tool holder. And the reason for that was I didn't want to have any risk of the tool pulling out of a collet holder. And some continuity context. You'll notice there's a lot of B-roll like this and time lapse. Those are actually two different valve covers in this project, and they're featured throughout the video, so you might see some features change throughout. And so here is the first quadrant roughed out. Here's a bunch of chips from that first quadrant. You can see it's starting to add up a little bit. And this is what the chips are looking like from that chip breaker tool. Now I've got a 1/2-inch 3-flute helical ball end mill, just to kind of give a nicer surface finish to the inside of that valve cover. We're not winning any awards for the inside of this valve cover. It just has to be functional. Here you go. This is a YG1 1/2-inch alu power. Probably would have sounded a little bit nicer with some coolant, but I wanted to kind of get a nice shot for this. And speaking of B-roll, here is a shot of the other valve cover with the GoPro trying to capture some stuff here. It's got a bunch of chips instead. And here is the surface finish from that YG1. Ended up looking really nice. Later on you'll see that I had to make some changes to that surface finish. And here's a deburring toolpath with a little bonus extended director's cut for you. After the deburring, I bore a little hole on this little surface here. We'll talk more about that in a minute. Now this one was a little tricky. So part of the reason for this valve cover needing to be made is that it has a different valve train in it. So it's taller, and it also needs to make room for the larger rockers. Horrible noise alert, I'm sorry. Yeah, you can hear it from outside. Yeah, it's 3 in the morning. Yeah, my neighbors are cool. They're fine with it. Don't worry about it. And so here's the finished quadrant, including that bored hole on the right side I was telling about. So that allowed me to probe off and establish my work coordinates for the second half of this, since we had to move it over to the left. That allows me to touch off my XY on that bored hole and my Z off of the surface that I milled in the previous operation. I was able to tune any sort of tilt with a dial indicator so that I can have the edges of the entire valve cover be very consistent. So here we're back at it with the 3-flute chip breaker. This is going to spend a lot of time making a lot of chips and sounding like a foghorn for like 2 hours. And I want to talk a minute about this machine. This is a Tormach 1500MX. It is mine. I bought it. Um, I love it. It's great. Why would I buy this machine? It fits in my garage. I can move it around just fine with the pallet jack. It runs off of single phase. I don't have to jump through any weird hoops to use this machine. It's serviceable. It's repeatable. And I think their previous machines were great, but this is not like their previous machines. This is so different. I've been thrilled with this machine. And I'd be remiss if I didn't talk about the Saunders Machine Works fixture plate and the mod vices. I was able to trim the back two fixed mod vices within 5/10 of each other. And that's really what made this project work so well, having to slide this workpiece from the right side to the left side. And this fixture plate is very flat, within a few tenths of an inch across the whole thing. I was actually really surprised. Having a giant open cavity on the left side of this and machining the right side just means I have to clear out all of these chips. They were really getting in the way, and so it was a little annoying, but we're making do. You can see I'm really getting my miles out of this tool. I use it predominantly for most of the adaptive passes. Earlier I mentioned I've got B-roll footage from the other valve cover. Any footage that's time-lapse from this angle is also that B-roll valve cover. And then we're just going to do the rest of the adaptive around the perimeter here. And then move it on to the bulb and mill again. You can hear it sounds a treat. It's mostly because of that stick out I've got there. And this will finish up the inside of this portion of the valve cover and onto that horrible key seat cutter. Now listen, or don't. I really had to make do here. You can see how much clearance I had. I mean, maybe a few thousandths from the bottom of that collet nut. This tool really was all I could find in the heat of the moment, and to get this thing out on time. So, and onto that YG1 contour, and I get my first look at how well I had blended this profile. You'll see me inspecting the deburb toolpath here to see how well it blended those corners, and surprisingly, it did pretty good. I was happy with it. Now I had to worry about preventing the valve cover from deforming when I flipped it over and put it in the vices. So these guitar brace jacks actually came in pretty clutch here. Now machining the other side of the valve cover, I placed the valve cover flat on the Saunders plate and up against a stop, and I set that as my work coordinate offset. And I've got the shell mill taking off a ton of material here. The 1/2 inch chip breaker end mill that I used to mill out the majority of the other side of this kept the chips really, really compact. You probably saw that in an earlier photo. This, however, was probably the majority of the chips that I made. They were nice and curly and ribbony and beautiful, but they were also plentiful, and they really stuck around. They did not like to get washed down very well. All right, so now that we've got like $50 worth of scrap aluminum taken off the top of this, back to a very similar process. We're doing some peck drilling, and then we're going to move to our 1/2 inch chip breaker. Now, this is where I see a lot of people get grief, and I imagine I will also get similar grief. I'm using that same long tool to do this side. Now, I could have used a shorter end mill and a collet holder, and maybe a little bit faster. I just described that tool you saw me bore that hole with earlier. If I was doing a production run of something like this, absolutely I would change it. But all of my variables were set, and I had an ideal chip that I could manage as well. There is some benefit to this tool being longer, not hitting that material to the right. Later on, doing a contour pass, I do end up eating a collet nut against that material. And here is our third quadrant, almost finished. We're ready for the ball and mill surface. And here's a little B-roll of my garage workspace during that ball and mill toolpath. This next shot's kind of cool. I slowed down the time lapse to kind of show the finish a little bit better right here. But again, as you can probably tell, this has a feature on the top of it that is the second valve cover. And then here we're doing some counter boring for those through holes. And after this, we're going to be doing the contour. This will blend the top half that we just did with the bottom half that we did in previous operations. You can see there's a little line there. It's probably like 3/1000ths. I go back and dial it in a little bit more, but there is stock to leave overall for me to hand finish in these pieces. And now I'm taking the part out and putting in my new offset that'll be on the right side and dialing that in and referencing that first jaw on the back left there. Getting everything torqued down. And here I've got the Heimer. I use that to make sure that if there's a twist in it that I can kind of anticipate that and better match the two sides. And the rest of this is pretty much like we've seen 3 times prior, facing, spot drilling, adaptive clearing. Now, this project took about 25 to 28 hours. Each side is about 13 hours long. And a lot of that is due to the setup of this tool. It has a lot of stick out. I have that heat shrink tool holder, which is long, so naturally there's a little bit more vibration there. And I don't think the machine was limitation. The most I asked of this machine was during the face milling, and really it only hit 90% spindle load. It's worth noting that the machine can overload to 200 or I think 250%, but just for a shorter period of time. And that long reach 3-flute chip breaker end mill never really even exceeded 60% spindle load. Finishing up the top here, blended out pretty well. I didn't have any real complaints. You'll kind of see it after this next part. And then we're going to skip to a little contour here. This shot here, this is probably the nicest blend I got naturally. And keep in mind, I'm going to be blending 4 quadrants of this part. So I did have some stock to leave that I was going to hand blend later, which you'll see at the end of the video. And back to doing some more counter bores on those through holes. This next video, you'll see the rapids of the machine. And that was the end of that program. You can see it wasn't the slowest thing in the world. It wasn't the fastest thing in the world. Now here's some deburring. And I'll end up thread milling that board hole later on. I was really sweating that. That was a do not come back from mistake to be made, so I wanted to make sure it was solid. And here's a part fresh off the machine. You can see some of those tooling lines blending those 4 quadrants together. And on the inside, you can see the chip breaker was what I used to finish the inside of that as well. Here's the part on top of the raw material for the second valve cover. You can also see some of those quadrant lines there that'll get blended out later. And then also the inside, you can see some of those standoffs that I'll end up hand drilling and tapping. Here's some photos of what the chip management looked like. It was a whole lot of letting those fill up, scooping it out, and repeat. The last chips you see there, that's from that shell mill. You can see how kind of thick and fluffy they are. The chip breaker ended up compacting them pretty tightly. And here's some of that hand finishing process. Again, I'm trying to blend 4 different quadrants together. Overall, it wasn't that big of a deal. Had plenty of material left over. The top here, you can see what it looked like after being hit with emery cloth. It actually did not turn out that bad. And here's a shot on a large granite slab. There was no gaps or rocking, and I was really impressed considering I had to do that bearing surface in 2 parts. All that's left now is to bolt it up, start it up, check for leaks. I was a little nervous taking on such an ambitious project for someone who's still so green in the machining world, but all in all, I was really happy with the way it came out. If you have any questions about this project or the machine, or if you have any complaints or critiques, please leave a comment down below. Thanks for watching.